Hi, I'm Mai, and welcome back to Chem Mayhem, where I teach you about different chemistry concepts. This is part B of dilutions and understanding the concept, as well as computational thinking. With dilutions, it is the addition of more solvent to increase the concentration of the solution. To dilute something, it means to add more solvent and on a lower amount of solute in the solution. The higher the concentration, the more the solvent. With that being said, this formula helps us to identify the dilutions and of any given value that we want to find. So it reads M1 times V1 equals M2 times V2. M1 stands for the molarity of the original, as well as V2 stands for the original volume of the solution, and vice versa, coming from over here. The only difference is this is the final and this is the original with 1s and 2s. And another important formula that is helpful is V1 plus V added equals V2. So how much V stands for the original plus the added equals V2, just like 1 plus 1 equals 2. So to understand dilutions, we can compare the ratios. It's just a comparison of the ratios. So how will the volume of the initial solution compare to the volume of the diluted solution? Well, the initial volume is always less than the final volume. How will the concentration of the initial solution compare to the concentration of the diluted solution? The molarity of the concentration of a diluted solution is always less than the initial solution. The molarity decreases as more solvent is added over time. What happens to the number of moles of solute once the dilution is complete? The initial amount and final moles stay the same. However, the volume does not, and it decreases as used up. Now we understand the phenomenon of dilutions. We can move on to computational thinking and understanding how to calculate dilutions. So, part 1 of E reads 2.5 grams of CONO3 is dissolved in water to form 250.51 solution. Calculate the molarity of this stock solution. So, because we have grams, we always want to start by finding moles. So I'm gonna take 2.5 grams CaNO3O2. We want to get to moles. So we have the molar mass, which is 164.1 grams CaNO3 over moles. And we get the moles of 0.0152 moles CaNO3. From there, we can use the we have to use the milliliters to calculate how many liters. So since 1,000 milliliters is in 1 liters, we can time 250 times, or divide by 1,000, and we get 0.25 liters. And so to find the molarity, we have to do moles over liters, and we have that over here. So we have 0.0152 moles of CaNO3O2 over the liters to get the molarity. This is what we're asked for in part 1. So it comes to molarity of 0.0608 molarity CaNO3. The next problem is asking us, this is all old information from our last video, so yeah, nothing new here, but dilutions comes in part 2. It reads 50 milliliters of stock solutions has 750 milliliters of water added to it. Calculate the molarity of this dilution. So to be able to do that, we have to, of course, use our molarity formula, which is M1 times V1 equals M2 times V2. This is our original molarity, so it is M1. Since we figured that out, and as well as our V2, because V2 equals 0.25, which is how much of the solution we have in the volume that we were given to begin with. So what we're trying to find is the molarity of the dilution. So we have to divide by V2 to get M2. So we have 0.0608 molarity CaNO3O2 times 0.25 liters. And now we have to find V2. So this is where we use our V1 plus V added equals V2. All right, this 50 milliliters is our V1, and 750 milliliters is our V added. So all we have to do is, of course, add them together, which is 750 plus 50, which is 8. 100 milliliters. Since we converted to liters up here, we want to use the same units. So, 800 divided by 1,000 is 0.8 liters. So we have to divide by 0.8 liters to get M2. So then times our V1, and then we divide by our V2. We get 0.019 molarity CaNO3O2.